So I've received a couple questions now about the kind of data that the detectors produce and what we look for and how we read that data, and also about the precision and computing power of these detectors. So I decided to dive into that a little bit. Just as a recap, we're talking about the scintillation detectors that use a scintillator crystal like this one to capture the energy from some energized particles like gamma ray photons or energized particles from the atmosphere and convert that energy into visible light, which we can then work with and measure. And these detectors run on the same basic principle pretty much for all of them. And once that light is produced from the crystals, it then goes on to the next part, which is called the photomultiplier tube. And essentially this thing is like a reverse flashlight, and this is one that has actually had the glass shell removed. Normally these are encased in glass and kept under a vacuum inside of the glass. But starting at the bottom, there will be a material which, when the light from the scintillator crystal hits it, emits a few electrons. And then those electrons, because this is held at a high voltage, essentially get sucked up like a vacuum through this system. And each of these copper wings that you see here, or levels, every time the electrons hit one of those, they produce more electrons, which then get accelerated even more. And then this cascade of electrons multiplies and multiplies until we have a massively amplified signal. These essentially go from a few electrons in the beginning to having enough electrons to actually form a measurable electric current at this end. These parts that actually do the amplification are called the diodes, and each of these pins, some of them go down to a diode and provide them with the high voltage that is necessary for the acceleration and amplification process. And then the rest of these pins actually read out the data from the end of this. So once the electrons have been amplified and accelerated, they reach the end, and then they travel through one of these pins or some of these pins and are read out by some more electronics that go here on the end and attach to the pin. So in its simplest form, that's really all it is. It is a crystal which traps some of the energy from the original particle and converts that into light. And then that light hits the photomultiplier tube, or the PMT, which then converts that light into electrons, amplifies those electrons into a big enough signal so that we can measure it with simple electronics. But then that begs the question that we started with: what do we do with that signal once we have it, and how do we read that signal? Well, we start by asking, what are we looking for? We're looking to know when the detector detects a particle, right? So we will have some baseline signal with noise, and then we should see some sort of spikes or some sort of sign that we are detecting a particle. And how do we read that signal? We measure the signal by using one of these. This is a digital oscilloscope. These are ubiquitous in the scientific community, particularly in physics and electrical engineering. And anytime you see a science fiction movie or a movie that's displaying science, you will always